Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing the Chapter 4 test review, 4.4 and 4.6, which can be found on pages 193 and 194. Okay, so let's take a look at 4.4. Graphing from slope-intercept form. So the book will give us an equation, y equals 5/10 x minus 3. Now, yesterday, they gave us an equation and we had to create a table. X with the equation, y are ordered pairs. And we knew that we needed a negative, a 0, and a positive for our x's. And then that determined our y's, which gave us orders pairs, and we graphed. Well, today, there is an easier way to graph this equation without having to create that table. So when we look at this equation, we can see that it follows y equals mx plus b format. And we know that m is the slope. We know that m is the slope. And we know that b is our y-intercept. And a y-intercept is where the line crosses the y-axis when x is 0. Okay, so with this information, we can create our graph. So here's our graph. So the first thing I want to do, is start with my y-intercept, where the line crosses my y-axis when x is 0. So if x is 0, where does the line cross my y-axis? Well, it's going to cross at -3. Right here. This is my y-intercept. When x is 0, y is -3. This is my y-intercept. Now, I take a look at my slope. My slope is positive, which means it's going to go up. But we like slope to be in rise over run format, and this is a decimal. So we can do a couple of things. 0.5 is equal to 5/10, which is equal to 1/2. And we know that this is rise over run. So my slope is 1/2, which is rise over run. So that means I'm going to go up 1 and over 2. Up 1 and over 2. Up 1 and over 2. So I can use a straight edge to connect my points. And then the question asks me, what is my x-intercept? What is the x-intercept? Well, the x-intercept is where my line crosses the x-axis. So my x-intercept is 1, 2, 3, 4, 5, 6. So my x-intercept is 6, 0, where it crosses my x-axis. Another way of finding the x-intercept, or to confirm that this is your x-intercept, So the x-intercept is where the line crosses the x-axis when y is 0. Okay, so where does the line cross my x-axis when y is 0? Well, they gave us this formula, this equation, y equals 0.5x minus 3, right? So we want to know what is x when y is 0. So we can set y to 0, substitute 0 for y, and then solve for x. So we're going to add 3 to both sides. 3 equals 0.5x, those cancel. I need to isolate x, get x by itself, so I'm going to divide by 0.5. 6 equals x. Oh, would you look at that? X equals 6. When y is 0, x equals 6. And that confirms what we did with our graph here. When y is 0, x is 6. So creating a graph using slope-intercept form, I think this is much easier than doing the table like we did yesterday. It's a lot less work. You have to start with the y-intercept and then follow that point using your slope. And in this case, the question asked, what is the x-intercept? Well, where does the line cross the x-axis? And to confirm that, you can always use the same formula and set y to 0, and that will tell you where it crosses the x-axis. Okay? Now, sometimes they give us the equation. Sometimes, let's go ahead and turn the page. They give us an equation that looks like this. 8x plus 4y equals 16. And they want us to graph that. Well, that's fine and dandy, but this is not in slope-intercept form. I need this to look like y equals mx plus b. I need to rearrange this so that it's in this format. Can we do that? Absolutely we can. We need to isolate y. We need to get y by itself. So we need to isolate y, get it by itself. So the first thing I'm going to do is get rid of this 8x. How do I get rid of positive 8x? Well, I subtract 8x. What I do on one side, I must do to the other. So these guys cancel, and I've got 4y equals negative 8x plus 16. It's looking more and more like y equals x plus b, but I still need to get y by itself. I need to isolate this y. So I need to get rid of this times 4. So I'm going to divide this by 4. Then I have to divide everything on this side by 4. So y equals negative 8x. You can look at it this way, or you can look at it this way. It can look like this, or it can look like this. These are both the same thing. So negative 8 divided by negative 8x divided by 4 is negative 2x. And then positive 16 divided by 4 is positive 4. This is now in slope-intercept form. Y equals mx plus b. So now I can graph this. We know that this is the slope, and this is my y-intercept. So when I'm graphing, I want to start with my y-intercept. And in this case, my y-intercept, where it crosses my y-axis, is positive 4, right here. Now, my slope is negative 2 over 1. It's negative, so my slope is going to go down, and I'm going to go down 2 and over 1. 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 We'll use a straight edge to connect those points. And we have graphed this equation that they gave us, which we had to turn into slope-intercept form. But the big question is what is my x-intercept? Right here. What is my x-intercept? Well, it looks like my x-intercept is 2, 0. It looks like my x-intercept is 2, 0. But I want to check that just to make sure. I want to check it to make sure. So x-intercept, where does it cross my x-axis when y is 0? So I can use this equation, or I can use this equation. I'm going to use this one just because I think it's easier. So y equals negative 2x plus 4. When we set y to 0, we want to know what is our x. So we need to isolate 2x. I need to get rid of this negative 4. What I do to one side, I must do to the other. I want to isolate my x. I need to get rid of this times negative 2. So I'm going to divide by negative 2. What I do on one side, I must do to the other. Negative 4 divided by negative 2 is positive 2. These guys cancel. X. Would you look at that? My x-intercept is 2. And that's what we got right here. So graphing from slope-intercept form is much easier like this than having to create a table like we did yesterday. But sometimes they don't give it to us in slope-intercept form. They give it to us in standard form. And we have to convert it to slope-intercept form. Once it's in slope-intercept form, we need to find our y-intercept and then use our slope to create our line, our graph. And then where does that line cross the x-axis? That is our x-intercept. And you can always check it by setting y to 0. What is x equal to? So it creates this ordered pair, 2, 0, which is exactly what we had right there. Okay, we have one more thing to look at. 4.6. So in 4.6, we have to find the equation of a line. Find the equation of a line. Find the equation of a line. So they're going to give us a graph. And on this graph, they're kind enough to label a couple of points for us. So they've given us this graph. They've labeled 2 points, and they want us to find the equation of this line. Well, we know that slope-intercept form is equal to y equals mx plus b. We know that m is our slope and b is our y-intercept. These are the things we know. So we can take a look at this line, and we can see what our y-intercept is. Here's our y-intercept. When x is 0, y is positive 2. So our y-intercept is positive 2. We know that. Now we have to figure out the slope. We have to figure out the slope. And there's 2 ways of doing that. We know slope is rise over run. So we can say 1, 2. My rise is positive 2. 1, 2. My run is positive 2. So my slope is 1. Now, sometimes trying to find slope on a graph can be confusing. So we can always use the formula as well. Change in y over change in x, y2 minus y1 over x2 minus x1. So we can always use the formula too. And they've given us 2 points. So 0, 2 and 2, 4. We can label them x1, y1, x2, y2, and then plug these or substitute these numbers into this formula. 4 minus 2 over 2 minus 0 equals 2 over 2 equals 1. So now we know that the slope is 1. So y equals 1x plus 2. Here's my equation. And the 1 is implied. It's invisible. So we've now found or written the equation for that line. This is what we are reviewing today, 4.4 and 4.6.